Okay. It says I'm live. I hope I'm live. We shall see. We shall see. All right. We'll give it a few minutes before we really get into it. My headset says that it's low on power, so hopefully having it in the charger will be okay. Tell me anything about how about half full. That should be all right. Alrighty. So let's go have a look at what we've done so far. I've done some more work on my little test project that we started on the previous stream. So we have a few more things. We have a little punching bag here that we can hit. Did some more work on the gun. We have a mannequin that we can drag around, and we have a little bit more work on the cubes that we can pick up and do things with. So yeah, we'll see if we can do some more with that. Not sure yet. We'll find out. I just want to try out some additional mechanisms. There's still issues with the movement of the hands. There's still issues with some things not being the right strength and stuff. Actually, that reminds me that no, I'll leave that for now. So I've got some ideas, and I've been reading up on some things for improvements, but I don't think I'll do that tonight. So I don't think we have enough time to get into that. So I just want to go and look at some simpler things. Now, the first thing that I want to have a look at is experiment a little bit more with the gun that we already have. So I'm just going to go and run this. Now, this should open up in the right location. Let's see. Yeah, that's cool. We can now see that we actually have a normal screen with you guys in spectator mode. So let's go and get in here, and yeah, camera is too close by for this. So actually I'll do that again in here. So yeah, I'm gonna move that to the side. You guys won't be completely able to see that. I think that's one of the other things that we might start working on tonight, is making it possible to actually have this camera. That's too low. That's not going to be good. It's going to be too high. Yeah, it's to see if we can make this camera movable. So that might be a good thing. So after we do a few more things with the gun, we might have a look at that and see if we can actually do some pointer UI stuff. Okay. Try and match this up again in the proper location. This is not really meant for doing with a controller, so I'll do it with the mouse. Come on. Really? Why can I not move it with the mouse? I don't know. You guys are going to have to just have it slightly cut off then. That's all right. So, grab the little gun. Let's load it. There we go. And I am going to go move over here. And I'm going to shoot one of these boxes. Now, you guys can't see this. Oh, damn. I didn't want that to drop down. Okay. So, let me see if I can reach that. There we go. So, if I grab this. Oh, yeah, that's the other thing. I actually... I'm using a raycast right now to place my hands. However, let me see if I can get this right. Swinging too much. Okay, can I get closer to the camera? Camera, where are we? Camera. So, no idea if... Yeah, we can see some of the problems with this, but okay, there we go. All right, so I don't know if that's really visible on stream, but there are bullet holes in there. And that's done with decals. Now, there is a problem with the decals, and that is that they affect anything there, not just the object that we shoot. And I might do something with putting the hands in a different visual layer or something. Or I'm just going to leave that as is. I don't really care too much. Anyway, okay. Let's take off the headset. And that's good. By the way, if the sound's not good, or if the shooting is too loud, I don't even know if the sound is working. Let me know. Hopefully, it's all going the way that it should. Okay, let's just leave that like that. So let's figure something nice out for that. All right, so as the bullet flies, what is this? My cat's making a lot of noise in the background. I hope it's not too loud. So yeah, my bullet is nice and light, but it's flying quite fast. We're having a bullet velocity of 600 meters per second. I actually want to add that in there. And we can do that, interesting enough, by abusing range. Let's say that we go between that. Actually, I'm going to go in hence. And then there's this extra hinge flag that we can do. And we can do suffix is meters per second. Da-da-da. Oh, because I've got that wrong. Da-da-da-da. So now it nicely shows 600 meters per second there. That's kind of nice to have that as a hint. We have a scene that we instantiate when the bullet hits something. And then we are using continuous CD to make sure that the bullet tracks properly, because else it can skip over things and not hit them. And we're using our contact monitor so that when it hits something, it actually, or the physics engine actually makes a record of what it hits, and we can report on that. Now, at this point in time, we are implementing integrated forces, which is a physics callback that every physics object has, or rigid body has. I think it's part of rigid body, isn't it? I think so. Yeah, part of rigid body. So that gets called right after the physics runs, I think. And it gives us some state. Now, normally, that also means that you can do this thing here called custom integrator, where you can also add additional logic here that changes the physics. But in this case, it's just reporting. Now, I did get some feedback on Rocket Chat that we should actually be able to do the same thing with body entered. So I want to try that because that's a more clean thing. So because also we have contact monitor on, that means that the rigid body will fire the signals depending on what's happening. So we're gonna get a body entered when we hit another rigid body or a static body. We get an exited when we sort of leave that that body, and we have also got the same things with shapes. So if we want to know the exact collision shape that we're hitting, we can react to that. Now, in this case, we're only interested in which body we're hitting. So when we hit another body, this signal fires, and that causes this method to be called, and that tells us the body that we are hitting. Excuse me. However, it doesn't tell us a whole lot more about that. Now, the thing is, hey, Squarepeg, how you going? Nice of you to join us tonight. Now, in this integrated forces, we actually get this state object that gives us all the information. Now, supposedly, not sure if this is true, but supposedly, we're actually going to be able to access that both on the body that we hit, because any collision works two ways, and on ourselves. Now, we wanted, in this case, to get it on ourselves, so we need to grab it. And I think we can grab it from the physics engine. So let's see if we can make that work. So we want one of those guys. There we go. And we're going to go to the physics server 3D. And we're going to do body get direct state. There it is. And we need the body ID, which is just get rid. So in theory, that should get our state. So I should be able to say if state, and we're going to go and do something. So this is checking whether we have a bullet impact scene and whether our bullet is still alive, because obviously we're going to destroy our bullet after it hits, which we do on our lifetime counter, or when we hit something, just in case we get multiple bounces or multiple hits. I'm just going to put the return in here to make sure that our integrated... Actually, I'm going to just rename this. It's a old integrated forces, so that's never going to be called again. Let's make it private. Just so that we actually don't get that cold anymore. And instead, I am going to go and repeat this over here. Now we're going to say if we have a valid state object and our bullet impacted something and our bullet is still alive. Sorry, if we have a bullet impact scene, that's that scene that we define here that we're going to instantiate. And if we have more than one contact, we should, else we wouldn't have body entered, but you never know. Now, in theory, we should be able to do exactly the same as what I've done here. So let's just try it. Let's see if I can move this over here. Now, you might be wondering, Baz, that's doing exactly the same thing. Why do you want it to have it on the body entered? I don't know. It just feels better. Feels more logical to react on that signal instead of always doing something with integrated forces. Because as... oh, come on. All right. Let's check. Yeah, you guys can see it. Good. As the bullet flies, the integrated forces is going to be called every physics frame. And we're only interested in it when we hit something. Now, that worked when we shot the cubes, but it also actually works if I shoot my little table. And the only problem is you guys can't see that. So if I go like this, can you guys... Wow, that's not good. Okay. I need to get some targets that I can shoot, or I need to put this camera somewhere that... You know what? I'm actually gonna go and see if we can move the camera behind me instead. So, okay, let's just do that like this. Oh, I've got an itchy nose. Annoying. Let's go here. Let's go here. Let's go and move you like this. What does that look like? Yeah, that's pretty much near. I don't know why that sometimes bugs out. No, it doesn't bug out this time. It's so weird. Okay. Let's see. What does that look like? Yeah, that's better because now you guys can see what I'm doing. All right. Cool. Okay. Let's grab my gun again. Yay. And then I'm going to shoot there. So we can see that my bullet holes still work. That's a good sign. Cool. Okay. How does that look here? Yeah, you guys can see the bullet holes too. Very cool. All right. So that approach works. That's cool to know. I'm also quite happy with the camera placement, so I'm thinking of keeping that there for now. All right. So that means that we can actually get rid of our old integrated forces. We can see our little hit markers there. All right, so now we just get logic on body entered. That makes far more sense. XRT2 is not public yet, but I'm probably going to make it public either end of the year or like early January. There's a few things that I want to change before I make it public because I'm going to make some structural changes to the way that the character body works. And if I make it open right now, then, anything that you built, you're going to have to toss away. That just doesn't make sense to me. So, because I don't know if you've noticed when I'm moving around, the hands move further than that the physics hands can catch up. And I've got some ideas about how to solve that. Well, I've done some research online about how other people have solved that, and I'm going to see if that can be made to work in Godot. But that's going to take a lot longer than 2 or 3 hours on stream will let us examine. So we're not going to go get there. I'm sorry, by the way, I've got a bit of a cold, so I will be coughing through the stream, and hope that isn't too loud for anybody wearing headsets. All right. So what are we doing here, actually? Because this is obviously logic that I wrote off stream. And if anybody else is interested in it, so the only change that I did with the logic in the hat right now is get the state object from here. We're then verifying that we actually have hit something. And here we're going to go and grab some information that is confusingly named. So in theory, when the bullet hits something, it's actually ricocheting and potentially hitting other things, which is one of the things that I'm not entirely sure about, whether that is actually where it's better to use integrated forces, or whether we're okay with doing body entered. I'm not sure if body entered gets called immediately when we detect something. But a problem or a worry that I have is that in theory, the bullet could hit something, bounce off of it, hit something else, bounce off of that, and we get multiple contact reports. Now, I don't really care too much about the multiple contact reports, but I do care that every time that the bullet hits something, it will it will exert some force on that thing. So even though I want the bullet to be destroyed when it hits the first thing that it hits, it could do more things. Of course, if that's what you want, if you want the bullet to ricochet, and obviously something that you could do is make sure that the bullet loses its strength. But yeah, that is a worry that I do have. All right, let me catch up on stream, because Pecker, you said, Bastian, I've been slowly gearing up for commercial PC VR project. I've been on and off reference on the extra tools, though it's been rough being that I use C#. Yeah, C# is difficult in the sense that there isn't as much information available about how you do things in C#. Now, there are a couple of C# frameworks that you can reference. And I always forget what the GitHub, let's see if I can find it. GitHub, the thing is, he scoped nubs, but oh, hold on, maybe I put that. Sorry, you guys can't see what I'm looking at, but I want to find it first, and then I'll show what it is. Docs Godot XR. Here we go. All right, so yeah, here we go. So if you're on the help pages, there's a page here called Where to Go From Here, and you have this toolkit called NXR from StumpyNub, and this is actually a really, really nice toolkit that has quite advanced gun handling. But this is completely written in C#. So this is a good example project to look at for how to do things with C# and Godot XR. One of the things that I do have, as a goal with the new version of Extra Tools, and I'm not there yet. That's another reason why it's not public yet. But a lot what I'm doing here, and a good example is the gun, if I can open up that real quickly. Pistol. So one thing that I've really done here is this whole pistol right now that we created on stream last a couple of days ago is basically a complete normal standard physics implementation in Godot. There's nothing XR about this gun. The only thing XR about this gun are these two grab points here. and the 2 grab points on the slide. And even those, in theory, aren't necessary, because I'm working on more automatic logic. And the reason I'm saying that is, I want to move away from XR Tools' reliance on inheritance of scenes, because when you need to inherit scenes that are being made with GD scripts, you can't inherit them in C#. So with XR Tools, you really have to rewrite XR Tools to C# in order to make full use of it. There are a lot of components you can drop in because you can mix GD script with C#, but anything that requires inheritance falls apart. So I'm really trying my hardest with this new approach to make objects that you add to normal objects. So either by decoration, or what I've named decoration here, where I have a normal rigid body for the pistol, and then I have decorations for saying, you know, these are my grab points, and trying to put as much of the logic on there. The same thing kind of with the player. So for the player, for instance, you can see that the player is still a normal character body that you can put your own script on, but then you have this dynamic rig. Now this is one that you know, you still sort of mix and match. So there's some situations where you might want to inherit from that. So that's still where I'm working on making things better. The same with the collision hands, for instance, which is, you know, my new hand object. That whole implementation is hidden behind the node, and you should just be able to use the node as is. You shouldn't have to inherit from it, or extend it or anything like that, which should mean that XR Tools 2 should be usable in C#. There are a few exceptions, like for instance, the construct is a scene that you have to inherit, and if you want to use if you want to use the construct system, that is optional. The same thing with the staging system. If you want to use that, you will need to inherit, and you'll need to do a little bit of GD script and then build the rest of your application in C#. So hopefully the next version of XR Tools will be more C# friendly. But it's still a problem, right? Is that most people are doing GD script things, so it's hard to find good examples. But there is more and more. There are more and more people doing Godot XR stuff with C#, so there is more and more information available. All right, where were we? We were just going through this bit of code to explain it. So we're getting some information about our collisions. So this first function, get contact collider object, that just returns the object that we're colliding with. So at index 0, that's our first collision. So if we have 5 collisions, we have 0, 1, 2, 3, 4. And we just grab that in, and that's just the node that we're hitting. So in this case, when we're looking at our output, where I'm doing my hit to print that out, you can see that I'm hitting the CSG polygon object, and that happens to be that table. That is actually a CSG polygon object. Actually, I'll show that so that we can see where that name is coming from. So we have our, actually it was displayed table 2 that we just shot. And inside of there, you find that CSG polygon 3D node. So if I give this a different name, you would have seen that name shown over here. Yeah, it's yeah, that was, like I said, that was the downside of the current version of XR Tools, that you can't use a number of things in C#, but you can reproduce it. It's still a good guide to look at how you can do things, and then just convert the code over to C#. But again, something like Nubus's framework is maybe a better start if you're using C#, because everything is already in C#, and it's a really good framework. I'm really impressed with what Nubus has done. So definitely does a couple of really cool things. All right. So that is why what we're getting with that state. And the only reason why I'm getting the collider here is because as I am adding the bullet points, or the bullet scenes in there, or the bullet holes, is I'm actually adding them to that collider. So I'm doing an add child here. Now these two are more funky. Contact local position and local normal. I have no idea why they're called local. because there's nothing local about them. They're actually in global space. So I don't know why that name was chosen. That's an interesting one. I really hope that that's not a mistake and they were supposed to be local to the collider or something like that, and that they're going to change it at some point in time, because that'll break what I've built. But we'll cross that bridge when we get there if that ever happens. So with that point, so this is the point where we're hitting, and this is the normal at that impact point of the collider that I'm hitting. So I obviously don't know anything about the mesh that we're hitting, but if our collider shape matches our mesh close enough, we get a normal where we hit. So that gives us sort of like the orientation of the surface. Scrapback, will there be a full body IK example in XR2 2? I know that someone did work on that area in Godot. Maybe. Actually, one of the roads that I need to go down in solving my issue with moving the hands properly when the body moves is Oglo the Nerd. This message is now history. I'm going to bed. Good night, Oglo the Nerd. Thank you for dropping in really quickly. So that does require the main player to no longer be a character body but a rigid body, which require some skeletal link ups there to actually create a more proper skeleton. So I might go down that route and make that thing have a skeleton that can then be translated to an avatar. Because yeah, that's something that was always missing from extra tools. Malcolm did do a lot of work there. So there is a whole avatar kit for extra tools where you can animate a an avatar properly, and there's use of IK there. But yeah, the IK in Godot is. However, now that we're using Jolt, hopefully, as more and more of the specific functionality in Jolt gets exposed to Godot, we're going to get more and more into the territory where we can really start using Jolt's joints much better. And that's even something that I'm already experiencing or experimenting with here, because even the 6-off joint works a lot more stable in Jolt than it ever did in Godot physics. And you can build a whole skeleton with physics nodes and proper joints and get some form of IK working that way. Not quite sure how well that will work, but that's definitely something that I'm going to start looking into. Okay. So what are we doing? We have our impact point and our impact normal, and we're going to build a transfer from that. So we put the transform at the impact point, and then we're going to make the transform look at the impact point minus the normal, which means that I'm going to look in the direction of that normal. So basically, when my bullet hits a wall, the normal will point outward. So I am going to have a transform at that point where we hit, looking outwards. That's what we're doing here. And finally, I am instantiating that bullet impact scene, adding that to the collider, and then setting its global transform to that transform that we just created. So that's going to orient it, our decal bullet hole. It's going to place it on the surface of the object that we hit, and it's going to face outward so that we can properly see. Now it is a decal, so precise positioning is not required, in the sense of that if the collision shape does not perfectly line up the mesh, it'll still do good things. Downside of decals is if I put my hand on there, then the decal will actually appear on the hand. So there's some more work to do there. I could have done a bitmap, but then if you hit something on an edge, you'll have a sprite sticking out of the thing that you hit. So decals are nicer there, but it's also one of the reasons I'm using the mobile renderer now instead of the compatibility renderer. Is compatibility renderer doesn't support that, so we're playing around with the mobile renderer now. Finally, after I do that bullet impact scene, I switch my is alive to false to make sure that if there are multiple, or if my bullet does ricochet, only putting a bullet hole in that first hit, and we're queuing or free queuing our bullet at that point in time, because we don't want to keep it floating around. It's hit something, it's done something. Now our bullet impact scene is this little scene here. You can't actually really zoom in on it close enough. Plus that without anything there for the decal to work on, there's nothing that gets shown. But the important bit is that we do have a decal here, and it's orientated outwards. And that's also why it's wider in that direction, because the width and the height is going to define how big the bullet hole is. But the depth is going to make sure that even if we're not perfect on the surface of the object, the decal will shine through a little bit. This was actually the old, actually I can delete that by now. That was from earlier experiments where I was still using a quad to display the image. But like I said, that gives me some issues when you hit things on corners and stuff like that. We're also playing a sound. So when the bullet hits something, we get a pling sound. And that's set to autoplay. So the moment that this scene is instantiated in my world, bling, we hear the sound of the bullet hitting something. Obviously, it's a single sound, so it's going to sound wrong if we hit something that is wood or something else, but that doesn't matter in this time. The last thing that we have here is also a lifetime timer. We don't want to have the decal stick around forever and ever and ever. So after about 5 minutes, the bullet hole disappears. If I get into a situation where I'm just going to start using this for a machine gun and we get hundreds of these things, I might not let them live as long as that. It's now for a little pistol. It's okay. And the only thing that's in our script is actually that lifetime timer, because that's the only thing I care about. The sound plays automatically. The decal does its thing automatically as long as it's positioned in the right place. It's my little bullet hole bitmap there. So yeah, pretty sweet. That's how simple you make a oops, not a box. That's how simple you make a bullet hit something and detect what it hits and does that. Now, obviously, the thing that is still missing here is we really want to also communicate to the object that has been hit. Now, in there lies a choice. Excuse me. One thing that I often do, and I'm going to leave that out for now in here, is that I check if there's a method on the collider on the object that I'm hit, like do damage, and then you call the do damage with a damage number, so that you can say on the bullet does X amount of damage. But the other option that we have is that we can also do contact monitoring on the body that we're hitting and then react there. What is your opinion on Godot's 3D animation player generally and the blend tree? I love it, but it is a little convoluted in the sense that there are multiple animation systems that kind of work side by side, and it can get very confusing. I do use the animation system a lot in a lot of the projects that I made work with extra tools to get like reload animations working for the gun, shoot animations. So there, when you shoot the gun, there's a whole bunch of things that happen one after the other. So I animate the slide going back and forward. I animate loading in a new bullet, etc., etc., etc. Obviously, doing the flash, firing the gun, all that sort of stuff. In here, we're doing much more things automatic. Oh, I actually do use the animation player a little bit here, but I think only for the shoot at this point in time. So when I shoot my gun, which is here on the do action, if I can shoot, yeah, I do a little animation player here for shoot. So I do use it here, but I use it sparingly in the new one. Because most of the things are automatically handled by physics, which is kind of cool. However, when we start looking at other things, like for instance, the player character, if you have an avatar walking around, things start to get really interesting. The blend tree is really good at that point in time, especially if you want to mix animations with, going from a walk cycle to a run cycle to that sort of thing. Again, in XR, it's a little bit less useful as it is in a normal game. Although for XR, your enemies, obviously, you would do a lot. I made, where are you? It's not this one, it's the other one. This one. Sorry, let me look it up. Where is my entry? Obviously, it's an unrated entry because I am a. Here we go. So I made this little thing for the game jam that we had a little while ago, where we have got this little plushie, this Godot plushie that you can interact with. Now, this Godot plushie was actually animated by a friend of mine, and I do think that I have. Do I not link it here? I don't link it here. I really should be adding it in because I think that I. Oh boy. Nope. What did I call it? I do think that I have it on a repository here. Here we go. No dash in there. I think that one I made public. So you can download this this project, but that plushie uses a blend tree together with the automatic state machine that's in the animations to trigger it going from its walk animation to its sitting animation to its sleeping animation, etc., etc. It's really cool. Yeah, the biggest problem that I have with the system, like I said, one is that it's a bit confusing because it's very convoluted. There's so many different animation systems that all work together. You need to know how it works. And the other thing is just lack of documentation. I was lucky that my friend animated this, and I learned from that. And then I suddenly went like, this is actually really cool. If you use all the components that are in Godot properly, it's incredibly powerful. And I'm actually working on another project where I'm doing things myself now, where I'm animating some enemies and things like that. And it's really powerful. The whole state machine that's inside of the blend tree system is really cool. But try and find good documentation about it. That's really where we're trying. So yeah, maybe at some point I'll get to a point where I need to do something like that in in something that I'm doing on stream, and we might have a closer look at it. But I do really like it. I do really like what's in there. It's just learning to use it well takes time because it's a lot of experimenting to figure out how everything works. And you'll get it wrong for a long time until you figure out that, hey, actually all the things are there in the IDE. You just need to figure out how it works. Especially like changing from one state to another took me a while to figure out that. If I remember correctly, you need to right click somewhere and that creates a link between one state and another, and then you can click on the link and you can add some checks in there and stuff like that. So it's very powerful, but it's not intuitive. Okay, where were we before we got distracted on that one? So yeah, we got the bullet impact, we got the bullet logic itself. So yeah, I would normally do something here that I also say, if the collider has a do damage or take damage function, I would call that. But I'm not going to put that in there yet because we don't have anything. I might put a to do in here. Inform the object that we hit. we hit it and how much damage. Because that's of course the other thing is that the bullet does a certain amount of damage. Whether the object that you hit actually takes the damage is another thing together. And even with this is probably the wrong way to do it in that respect. Because for instance, if I hit a shield, we don't want a bullet impact on the shield. We want something else. So I would extend on that. But for now, for this as an example, this is more than enough of what we need to do. All right. So, do I want to do anything more with the pistol right now? Or leave that as is? I think I'm going to leave that as is. So, I'll actually show about a few of the other things that that's in here, which means that I need to restart our good friend. Because of course my headset timed out, so Steam Link crashed. Well, didn't really crash, it just timed out. And says, host not responding. Yes, I know. Come on, let me quit you out of here. There we go. I don't know, I need to restart. I wish there was a smarter way that it would just re-establish connection. Because the funny thing is that half the time when I do this, no, this time it works right away. That's cool. Okie dokie. Right. Just peeking out the underside of my my headset. So that was the gun. Now we also have these boxes. Now these we built on stream last time already. I just made them a little bit, they were all the small ones, but I made them different sizes, and I gave them a little label about how much they weigh. But the other thing that I did is these boxes no longer have grab points. What I'm doing instead is when I'm close enough with my hand to grab, and I press the grab button, I actually do a ray cast from the hand to the cube, and then wherever that ray cast hits, that's where I place the hand. Now, we're not doing any posing yet, but that's okay. So that's that one. Now, the other one that was really cool is this little guy here, this mannequin. Maybe we'll spend a little bit more time on the mannequin just for fun. This is a ragdoll. But the ragdoll's currently turned off. Now, the moment that I pick him up, he becomes a ragdoll. I'm going to go a little bit closer to that. But he's a ragdoll who's made out of, I don't know, like plastic foil, because he's getting very bubbly and everything rotates. And that's because this little guy doesn't actually have the right joints. It has pin joints, and they can move any way they want. Now, I can pick him up on two places. And again, there's no grab points on this. This is all done with the raycast. And here you can see that our collision shapes are far from perfect for what we need to do here. So I might actually also work a little bit more on the collision shapes here. But the other thing, of course, is that, yeah, we need to get better joints. Goodbye, Mr. Ragdoll. So that's a Mr. Ragdoll. Did we just walk over him? I think so. And the last thing that I created is this punching bag. So I can just punch the punching bag. And now, at this point in time, the punching bag doesn't push me around yet, which is kind of cool. But in theory, of course, if the punching bag hits me, I should be able to, I don't know, should be able to push me back. Oh, that would have hurt if that was real. But yeah, this is just a rigid body with fairly high weight hanging off of a pin joint on the top of that arch. And that's all that thing does. But it works. And that's something that I find really cool about this is, we're just doing everything with pure physics. And that's actually something that I want to do some more stuff with. Just create some more physics things. It's hot in here, so I'm sweating. That is a bit of a nuisance. And just see how far we can take that. Now, we need some stuff for that. And the question is, what are we going to use for that? Well, we can always go to my good friend Kenny. Let's see if Kenny has something that we can easily use to start So we need 3D assets. And we really need to have some interior things. Or am I going to do that with... Well, actually, the other option is to use this. Because we got doors like this. We got little desks that we can play around with. Because Kenny's got something like that as well. But I wonder which one we should use. I remember that Kenny's... Which one was Kenny's? I know that Kenny has got a... prototyping. Kind of cool too, actually. The mini arcade, that would be something cool to do something with as well. Food kit, building kit, no. It does have doors. There was another one that that I used to use. That was kind of cool. But I can't find it anymore. Oh yeah, I think it's this furniture kit one. But the thing with this one was that I had a lot of problems with things not being centered correctly. But the other thing is I want to do something with the door handles. The big question is, does this... No, it also has this little dots there. Now we can still, you know, we can do some CSG stuff to create some door handles. So are we going to use this one or are we going to use this one? Difficult questions. Does this have walls? This only has doors. It doesn't have walls. I'm going to do the furniture kit from Kenny. Why not? Yeah, I already donate to you, Kenny. I am on your Patreon. All right. Let me quickly unzip that and put that into our projects. Now, might as well put that here so you guys can see what I'm doing. Here's the furniture kit. Now, I always like copying at least the root folder so that I have the information about where it is coming from. Even though it's CC0, I like to have that. But I'm not going to copy everything else because that's just a way to waste space. Excuse me. And I'm actually... Am I going to go for the GLTF ones or am I going to go for the OBJ ones? That is an excellent question. I think I'm going to go for the OBJ ones. There's no textures in the texture folder. Does that mean that there are no textures? Well, let's just start with the OBJ ones because they give us a little bit more control. And I remember that there isn't anything special about the GLTF ones, so OBJ it is. All right, cool. Yeah, I know you're going to complain about that we do not do ambient light and stuff like that. Those are really useless errors in this case. Well, they're useless to me. You know, an artist might really go like, "How dare you not do my lighting the way that I set it up?" So here we have all our beautiful objects. Now, one downside of this is I thought that this was going to give me... Yes, it does. Okay, cool. So Actually, now I remember why I should have used the GLTF ones. Yes, I do need the GLTF ones. Okay. Okay. That means we're going to actually delete this from here. Boom. Because that removes also all our temporary things. And the reason I want the GLTF ones, and I now remember, is because if I use the OBJ ones, and I have, say, a cabinet with drawers, that's going to be one mesh. But in the GLTF ones, they are going to be separate meshes. So. And we might need to do a little bit of playing around with that and making sure that it does it in a way that we like. But there we go. Thank you. Yay. Let's go to our main stage. All right. Let's start with a drawer. What is a nice little drawer thingy? We can make a toaster work. That would be fun. No, I want something with drawers. Do I want the kitchen one? I thought I had a bedroom one as well. Cabinet drawer, this one. All right. I'm just going to go and drag that in here for now. There we go. Where does it put it? Here. Ooh, that looks way too small. All right. So we want to apply the root scale. Yeah. Well, let's just see what happens. Actually, let's go to advanced for that. Because maybe... No, that's all good. So here we can actually see that we have a cabinet. Yay! But we actually have a door on the cabinet, so... I guess that's just a node. Is it? No, it's a mesh instance. Oh, the mesh is just separately... Okay, that's right. So that's a little door that we can open, and that's a drawer. And that's the thing that I found important, that we have those all separate. Now, let's start with figuring out how much bigger this thing should be. Let's actually go and have a look if we can sort of guess. Actually, we could probably just try that out over here. Let's see if we make that 5. That looks like a really big one now. Let's go for 2. That looks still so small. 3. That looks about all right. Come on. So this is what I meant with that I didn't like the positioning, that it's on the corner of this thing here instead of where I expected it to be. But that's all right. So that's now scale 3. I'm actually going to turn that back to 1 because I want that to be scaled on here. And let's go and re-import that. That's now good, like that. Now the big question is that actually on here? No, that's still scale 1, so it actually applies that to the object. Now, I don't know if it applies that to the meshes or to the individual nodes. That's okay. Let's move that to the side a little bit. And let's go and rotate that a bit like this. I don't want that underneath the punchy bag. I just want that to the side a little bit like this. All right. Cool. Not quite sure why I did that because we're going to make an inherent scene of that, and that's what we need to get in here. So yeah, we'll figure that out. I want to do a little bit more in here because there's more that we can do. And one of the things that I want to do is the cabinet itself should actually be a static body because we don't actually want, I could make it a heavy rigid body so that we could push the drawer around, which maybe is nice. But I think that's overkill. So we're going to make this a static body. And we need to do that on here. So that this one is going to be a static body. And we need to be careful about what sort of shape that is. I'm actually going to go for tri-mesh for now because we need the insides of this thing. We can't just turn it into an encompassing box. We actually need that to be holes in there, or our door and stuff won't work. Now our door, we also want physics, but that guy, I guess that's then dynamic. And you know what? I'm going to make that a tri-mesh as well. Tri-meshes are a bit expensive, but I think for something like this, that will be fine. And then our drawer is the same thing. We're going to do physics. We're going to make that dynamic, and we're going to make that also a tri-mesh. Let's just start with that and see how well that works. Okay, cool. Re-import that guy. All right. However, we cannot use that as is. So we can't say that as a branch as a scene, I think. Or is that the better way to do it? We could do that like this. Just have a helper node for placing it. We put this on there. And then we call that cabinet. Let's go and save that as a scene. Put it in objects. Furniture. Furniture or furniture? I don't know. My English is not that good. Okay. According to Google, it's furniture. There we go. Yeah, it's great there. Cool. It's moved him in the wrong place. That's really interesting. So there's some interesting things that happen when we make it. Do that now. Why is that saying? Okay, so it doesn't like that we are using that type. Why is that called clone? So we have a static body for our thing there, but then our drawer and our door are now nice rigid bodies, but it's complaining about those. I do not know whether that is true for Jolt as well. Let's just keep it that way. But the nice thing about doing it this way is that we can always change our import settings and then re-import it. All right, so door. Where is our door? So our door, for some reason, is inside here. It is not positioned right. I think the door was on the bottom, if I remember correctly. So we're going to go and move that down. Actually, let's go and do a... Yep, that's good enough. Well, I can't really see. Let's go and do it like that. All right. Because one of the problems that we're also going to run into... actually, that won't be a problem because we are, suddenly realize, because we're going to use joints, we're actually going to exclude collisions between our main object and the other ones. Now, the other thing which is really weird, did I just move that wrong? I did, didn't I? Idiot. Yeah. 0, So I move the mesh instead of the object. You should not move the mesh. We need to move the rigid body. So let's try this again. Probably like so. Move that like so. I wish that it colored that properly, but I can hardly see what I'm doing. So we're gonna go and put this in as good as we possibly can. Cool. A little bit more. A bit more. I think that's good enough. All right, so let's go and put the drawer back where it came from as well. So yeah, these are the sort of things where you're sort of going like, that is not completely working the way that it should. But it's fairly easy to clean up. Now, the other thing, of course, is these things are not textured. And I'm happy to keep them the way that they are right now. But, yeah. Okay. I've also changed or made the collision hands bit by this point in time that we can't grab static bodies yet, which is great as well because we don't actually want this guy to be grabbed. Now, right now, if I would run this, we'd be in trouble because the door and the drawer are not attached in any sort of way. They're rigid bodies. They would completely panic with the collision shapes of the what you call it, of the drawer of the desk, and it would all go really bad. But that's okay. That's not what we're going to do. What we're going to do is we're actually going to start using some joints to make this work within the constraints that they should work in. So the first joint that we want to do, and we're actually just going to make them on the roots, which is fine. It doesn't really matter where they are. But the first one is going to be a slider joint, just like we used before for our slider in the what's it called? For the slider on the gun, we're going to also make a slider work over here. Cool. So this guy for node A is going to be our static body. Cat, what are we doing? What are we doing? Why are you throwing everything on the ground? Trying to get my attention, huh? Yeah. Crazy cat. Get rid of that because we don't need it right now. And then for node B is going to be our drawer. So our drawer is now controlled by a slider joint. Now, again, the slider joint is going in the wrong direction. So we need to go and, no, 90, I think. So now we're sliding in that way. All right. Right. Yeah. That's the exclude. So this also prevents the drawer from actually hitting the static body and causing havoc with that. We're going to purely be limiting it by this. Now, with the slider on our gun, we found out that these were reversed for some reason. So let's see which one of these two we need to adjust. So that was probably the wrong one, assuming that this is going to work the wrong way, the same as the other one. So I'm going to put that on 0, which means that we're going to stop there. And let's make this for now half. Let's see if that it's probably going to be once. Hey, cat, stop trying to break my green screen, please. do you want? What do you want? You want attention? Because you're wondering who is he talking to, right? But please don't break my green screen. That would not be a good thing. Sorry about that. My cat's trying to get my attention. You want some of this? Yeah, want some of this? Here, put them in. Here. There you go. Yay! Okay, that might keep it busy for a second. Really bad giving my cat snacks to make her happy. So we'll see if that actually goes the right way. It might be that it actually works the way as expected now. Could have everything to do with that. This rotation might be weird, but it is what it is. All right, so we're gonna put a second joint in there, and this time we're gonna put a hinge joint in there. So that's a rotational joint, and we're gonna move that to the corner of our door. There we go. Same thing. We're gonna make the parent the static body, and the child is gonna be our door. However, that's again in the wrong direction. Now, we already have a limit from 90 to minus 90, which is interesting. That is way too much, but how does it get that as something that it draws? I go to 45. No, it doesn't really show what it does there. Hoping that it would show properly what the angle was. However, I'm going to assume that now the door goes like a Lamborghini door, and that's not what we want. So I'm guessing that this should be like so. Oh, now we can see the rotation properly. Okay. That's kind of cool. So let's see. Oh, why does it rotate so weirdly? 0, 0, 0. Let's just do. Okay. No, that's not good. Yeah, that's just what I wanted. So we can now see that we do have, well, we've got a 45-degree rotation there, strangely enough. But yeah, one of these is going to have to be 0. But we will see what it is. Oh, we need to enable that to show what it's doing. Now we can see. I'm gonna hide. Oh, I can't do that on here. Oh, yeah, I can do that for now. So if I make that 45, what a weird way of drawing that. Why do I have two pie shapes like this? It's like I have a double joint here. So which one's the correct one? I think it's this one that's going to be correct. Okay, I want to keep this there. So now I've got that like that. No idea if that's the correct one, because I don't know what the second pie shape does. But that's the pie shape that makes sense to me. That reminds me, do I need to, oh. Is that maybe why it was doing weird on the rotations? No. Did I need to, no, those are always. We don't have any limits there, that's cool. We don't want a motor, that's just for automatic things, or do we? Yeah, it turns the hinge. Guess we could use that to try and automatically close the door. Now we're going to leave that alone. Okay, so in theory, we should now be able to move our rigid bodies. But they'll be Yeah, we'll see. We'll see how well it works. So we still had that in our main scene, did we not? Yeah. Oh, why is that? Oh, because I hadn't saved it. Save. Let's see. Yeah. All right. Let's just see what it does, and let's also see if it's not. Yeah, I'm not sure what that second pie shape does, but okay. I need to restart Steam Link, of course. Come on, figure out it. You're no longer there. All right, now I bet you that the thing is going to be too much on the ground, but we'll see. I can actually turn like this because I have more room in front of me now. Okay. So we're at least not starting with craziness. That's a good sign. And it is, I think I need to make it bigger. But I can slide it out. It doesn't go further than that. And I can slide it back in. And I can also push it back in. So that's with grabbing. That's cool. But the bottom one is, oh, that's really gone wrong with the, doesn't like the handle. Yeah, that is too close on the ground. I probably need to put this up a bit, but it is working. So that's pretty cool. All right, so we got lucky with the setting up. So that pie shape we were correct about. It's the second pie shape that's important, and we were indeed correct that our slider joint works in the wrong direction. But I'm not complaining. And we got very lucky that the slider joint actually had the right size. Now, I think that one of the things that I do need to do is, well, let's first make sure that the size is a bit better because it was too small. So we go back to our file system. We go back to our drawer. We still have that there. We go back to import advanced. Also, it was fine with the collision shapes. It didn't really care about that. I think 5 is going to be. Well, let's see if we do it on 5. Boom. Now, obviously, this is going to change everything being in the wrong spot. So we need to reset that all. Yeah, lackluster. That's definitely what I often do as well when I really can't figure it out. And we just go into that. Which one? I'm not really making a game. I am just experimenting with a lot of framework stuff. To just get these things to work the way that I want. Oops, that's not what I wanted to do. So this is the drawer. We need to move the drawer up now. Okay. A little to the right. Because that is the downside of making everything bigger. Everything is now in the wrong place. So now we do the same thing with the door. Of course, make sure that we have the rigid body that we move. Okay, so the door goes into place. There we go. Now we want to get the hinge joint back in place. So then that is at the right spot. In this case, it is lucky that our origin point is there, that at least we don't have to put it further back. And obviously the slider joint is also in the wrong spot. So this direction doesn't really matter. This one is, it doesn't probably matter as well. The front back matters. But I like lining it up because it's nicer to see. Now, seeing that we've made it bigger, this is probably not big enough. So let's go for 75 and hope that's good. Now, the other thing that I want to do is on this, I want to go and decorate that with the grab points. And we're just going to move that over here like that. Let's show that guy. I just do it flat. I'm just trying to avoid this thing when we grab this that it starts bugging out on there. So I think that will be good enough. Turn that off. So for the right hand, do we want to? I guess we're going to have to. Okay, so this is going to be for the left hand. Okay. That's going to go left. That's going to be go right. I'm also going to make both of them exclusive. So that's a new option that I added in, that we can only grab it with one hand at a time. So this is going to be for the right hand. And that needs to be rotated then. There we go. And that can go back like that. At some point, we'll make those things work much nicer. Excuse me. All right, then the same thing for our... Oh, those were supposed to be for the door. Doesn't matter because we want to do exactly the same thing. Actually, let's go and copy those first onto the drawer. I said copy, paste. Really? You can't do that? Copy. Oh, it doesn't like it if I... Doesn't like to be copied. Okay. So be it. So what I'm then going to do is I'm going to do it like this. Left. Exclusive. Right. Exclusive. And now we can move these. He doesn't like that very much now, does it? I think because I did that copying, I'm just going to go and open this again. That's the downside of creating these extra nodes in the background. It can sometimes get a little confused. These actually need to be on the drawer. Yeah, so now those two guys are happy. Let's also make sure that those are not shown. And now these two, we can move over here. Like so, okay. Okay, no longer show you. This one we probably want to have a little more like that. Again, we don't need to be very precise, but at least we have it. And again, you know, I don't have any posing logic yet and stuff like that. So it's just getting it as good as we can. All right. Let's see if that works a bit better than what we had before. I'm going to use the same trick again and just go sit sideways. There we go. All right. That's a pretty big table. At least now I can more easily grab it. And because now my hand is there, and I haven't got a maximum distance yet to it, I really need to do something about that. But yeah, I can push it all the way out. Oops, and I can push it all the way in. Happy Jojo. Now, if I let go, I still have that it sometimes clips through the object a bit. But I can close the drawer. See, sometimes my hand just gets stuck on it. Something that I still need to improve. And if I bend down, I should also be able to open that door. Interesting enough, it does pull closed. And that's probably because it's actually it's colliding with my hand at this point in time. So that's the next thing that I actually want to do. I actually want to make that, I want to force that and make sure that the drawer either stays open or closed. And we're going to do that by creating a little bit of a spring force, similar to what we were doing with our slider on the gun. We're also going to move our table a little bit to the left because it's against our boxing thing. Hey, cat! my cat suddenly decided to lie in front of the monitor. That's funny. Go away. All right. So for that, we're going to create a little script here. Or are we going to actually create that on this? I wonder what is smart there, because it's something that we would eventually want to reuse. Yeah, because there is no logic, I think, for that on this. We do have. So that's our hinge joint for our turn. We do have a motor, but I don't really want to use that. But I kind of do want to make it work in a way that that we can reuse it, that I can put it on any hinge joint. Just like we have the logic on the gun, it would be really cool if we didn't have to write that every time. Okay. Ugh. Still behind on the stream, but that copy paste node bug has been around for a couple of versions now. I'm sure there's a report for it. That's one of those things that the more complex the editor gets, the more likely those sort of things snuck in. All right, let's first go to our main stage and let's go ahead and move our. This bug is also very annoying. There we go. I didn't actually check if you guys could see me operate the what do you call it? The cabinet properly, because I wasn't paying attention to whether the camera is actually pointing in the right direction. That's the other thing that we need to do at some point, is better camera control. What is this complaining about? Nothing. Hold on, I'm just checking a few things that are coming in. See if there's anything important. Oh. Ooh. Huh. That was quick. Yay. This went live. Ah, cool. Go. Cool. So our new blog post just went live. Yay. Shame that the should have probably renamed that, because it actually turned out to be December. I forgot to turn that on. I did name it nicely December here. Oh well. Small things that we miss. Anyway, here's a new blog post. Yay. Cheers. And there's a new forum thing. Buying a headset for video. Okay, that's something that I'll have to react to tomorrow. Done. So yeah, let's just go and create a script on here. I am going to leave this in the project right now, but maybe eventually these are things that could become a nice add-on on itself. I'm just going to do physics helpers. Oops. Helpers. And this is going to be called a springed hinge joint. There we go. Create. And we're going to actually give that a class name. Class name springed hinge joint 3D. And with that name, I actually want to rename that here so that we can see that. And now we want to have two forces, or do we want to just have one force and just use that in either direction? We do have this linked to a static body, so that's kind of nice. We can probably check that. Oh, okay. The other thing is, when we look at the drawer, this is the door. We don't have any rotation here. Okay, we're gonna assume that this is always, because I don't think we're gonna get the rotation on the hinge joint itself. Or do I have a... No. It would be nice if we could get the angle that we're actually using here. However, we do have the transform here. So we could bring our doors transform into the local space of the hinge joint. So that way we know that it's always in the same, yeah, so let's go and do that. So let's start with a physics. Do we do that as physics? Yeah, we do that as a physics process. We, in this case, don't really care about our delta. So we now want to get, what's it called? Node B. Node B is the one. Okay. So what we want to do is 3D, and we're going to get our node B.global transform. And we want to get that in the local space of this one. So we're going to go get our global transform dot inverse times that. Now, I don't really care about the location, so we can probably even just take the basis of this and just do this on the global basis. Okay, cool. And what I want to start with is, now that we've got it like that, is we want to get the angle of our bases and see if we can relate that to the angle here. Because it's going to rotate in only one axis, and we could get that from there. All right. Because one thing that we could probably also do is, now that we have that, is that we just need one of the, well, let's first see which, no, I don't want to go for, I want to go in the other direction. I want to get our Yeah, get Uber. So let's just go and print that. Oh, why? No path. Okay. For B physics buddy is get node B. I really should give this nicer names, but I'm just going to take it nice and easy for now. E dots get Euler. Because I'm just interested in knowing which angle we need to look at. So let's go and see how well that looks. And whether we get some info that we need. All right. So that should be working the whole time. You guys can't see the, oh, actually I can. I'm just going to go and do that. So we can see that we have a very low negative angle, which is interesting. But yeah, that's all right. So now let's go and grab our door. This is a problem that we have right now. Ha! I tricked it. Oh, there's no inside of the door. Kenny, why did you not make an inside on the door? I guess he never assumed that we would open it. Okay, those are in radians. But also, because we're doing Euler angles, we're not gonna get that in the way that we want. Okay, there has to be a better way to do this. Okay. Okay. Let's do this in a better way. All right. I'm just going to create a second hinge joint. And I'm just going to drag that out a bit over here. Why is that not drawing anything? Don't worry, I am going to toss this away. Okay, so our rotation is in that direction with that up. Oh, I could have just looked at the local. Why don't I do that? If I just do this, then I get it in the local thing. Now, interesting enough, we have this upside down. I want to have that right side. Oh, no. I do need to have it that way because that's the only way that I get the angle in the right place. But that's okay because we're going to negative 90 and eventually that's just all that we care about. So, interesting that that's pointing the other way from this. Because if I make this 10, then it's this one that changes. So we need to get that vector, but we need to take it the other way around and then take the angle with what it has moved. Cool. The red vector is the X vector. All right. So still have our basis like this. But we're going to only care about our X vector. All right. Angle. It's that's going to be wrong right now. I'm not done yet. Now, if I remember correctly, we should have an angle 2. Okay. All right. All right. Angle. I'm glad to be of service, Vagnish. Vector 3 0, 0, and 0. Actually, I don't need to negate that because we're just caring about the angle. And as long as we start with a unit vector, that's going to turn the right way around. Now here, we do want to do a rad 2 degrees so that we actually turn that into something that we can read. Okay. Cannot, oh, because that's already a basis. Oops. I just need to get the X out of that. All right. Let's see if that now starts making more sense. Let's start with that just being a little bit smaller so that we can actually see what's happening. Well, you guys can see what's happening. I can't. All right. It's again, it just does the close thing again. Okay, that looks like it went up to positive 90 instead of negative 90. Okay. Yeah, that's interesting. But that's all right. That's workable. All right. Okay, if I do that the other way around, we now get minus 90. Okay. Yeah, that's going to go haywire because we're giving it too much force, but that's all right. Anyway, still 90. Oh, that is interesting. I have a feeling that our angle is always going to be positive. Okay, let's test that out. Long live live editing. Okay. Where's my keyboard? What happens if I now push on this? Indeed. So we always get a positive angle out of that. That's okay. That kind of makes sense. We then just need to figure out what the direction of that angle is. All right. So, sorry, I forgot to switch it over back to showing the game, or the demo, where I pushed the door into the cabinet. All right. So, what's that? Angle to give vector in radians. Do we have? Well, we can do a cross. And then depending on whether, no, not a cross, sorry, a dot. And then depending on whether the dot is positive or negative, we get that. Now the dot itself is actually already the angle. I can actually just do a dot and then an ACOS, I guess. Or no, sorry, that works the same way. That would also give a angle. Oh my, nice. No, we do need to do a cross, and the cross would tell us either whether it's one way or the other, depending on which direction the cross is in. All right, so player. Where's insert? I'm looking at the wrong side. Okay. Okay, let's go and put that into a variable. Rest. Seeing that we now know that this is in unison, we can just do it like that. And in this case, all we care about is cross that line. And now I just need to see, because I think it's, if it's positive in one direction, then, you know, we need to just flip our angle around. Let's actually keep it fun and keep that 45 in there so that we can indeed see it flip around. All right, let's see if that now does what we want it to do. Okay. Now, I do find it a little bit silly of myself that okay, there you go. Now, the other thing, of course, is because that does not have a back, that door's collision shape is probably also really wrong. Okay, so there we can see. You know what? Let's just take that out. I want to see the whole. Oops. Sorry, I was doing that on on my virtual keyboard. So, okay. So maybe I was looking at the wrong. So maybe it's going in the XY, and I should have looked at that. So you can see it's -1, probably negative. So let's see what happens. Oh, make sure that you guys can see it. Let's see what happens when we then close the door again. And then we now see that it gets positive. So if it's negative, then we need to negate our angle. If it's positive, we are good to go. Sweet. We don't really care about the value. We just care about what it is. All right, cool. So that's a lot of data. I want to see where it actually flipped around to make sure that we're not going to get in trouble with that. Oh, there is so much in the logs. Where are we going? Try and find the needle in the haystack. Lackluster, I am always a fan of getting models for demos. So if you're willing to donate some models, I am always interested. Okay, so yeah, that flips. Because when it's exactly matching, there is obviously a point where this is going to be useless. However, the Z value is never going to be a complete waste. So what we're going to do is if that's smaller than 0, then angle is minus angle. So now we have nicely our full rotation 180 degrees one way, minus 180 degrees the other way, and we can start building some logic on that. All right, so actually let's make it a range. I like doing all my inputs in degrees, even though behind the scenes we will want them as radians. And actually, there's again a oh, that should not be one. That should be one like that. There is a hint for that. But of course, there's no help for that hint. That might actually be in here. Radians as degrees. That's what I was looking for. So in this case, the great thing is that that's now going to display as degrees, and our range is going to be in degrees, but our variable is actually going to be in radians, which we want because our angle is going to be in radians. All right. Var lower spring limits. And this is going to be called higher spring limits. Actually, let's call that minus 180 and 180 so that it's right at the border. Okay. And now we're going to say export range 0. Let's just say 2000. And I don't actually know what variables we didn't, but let's just see what that does. Okay. Cool. So with a lower spring limit of minus 180, we're never going to go over minus 180. That would actually turn our lower limit off, and our higher limit is the same. So the idea here is that we're going to apply a force to our door to either when it's below a certain angle, we're gonna force it closed, and when it's above a certain angle, we're gonna force it open. Cool. So, oh, I already removed my print. If angle smaller than lower spring limit and lower force is bigger than 0, and we do that. Else if angle is bigger than higher spring limit and let's think of this and higher force. Getting late. I'm getting a little bit slow in thinking. Now we're gonna go do that. Okay. Now we need to do some calculations to make sure that we get the right values that we're going to deal with. Okay. And we're also going to need to figure out, oh, we can do that as a torque force. So that will be cool. All right. That's a good question. How do we do the torque force here? So we're going to have to rotate around the blue, and that makes sense because it was the Z that was our thing. All right, cool. So we're going to do closing force when we're nearly open, and we're going to do an opening force when we're nearly, oh, sorry, we're doing closing force when we're nearly closed, and we're doing opening force when we're nearly open. So in this case, because we're going from 0 to minus 90, that's actually, because the lower in this case is the opening. So let's say that we want to go to 75 and, oops, We're gonna leave that at 100. And then our higher spring limit is going to be minus 15. So the last 15 degrees is going to cause it to close, and the last 15 degrees on the fully open is going to cause it to open. All right. Cool. So the important thing is that it's obviously going to be a force that needs to be in the local space here. So we need to do our same little trick that we did with getting our angle. We need to work that way up with that as well. So we know that we need to start with the rotational force on this, which means that this is actually going to be way too much probably. So let's go and make that higher force a lot lower. And we're going to actually go and rename this to torque. And we're actually going to make that 10 for now. And that means that we're going to go in increments of 0 to 1. And we're actually going to make that 2. And let's do that same here. Torque. 2. 10. 0, 0, 1. There we go. All right. Cool. Cool. And we're going to do that. And we're going to go do that. So so let's get our torque value here. And in this case, we're going to make that lower torque. One of these is going to have to become negative. We just need to figure out which one. So one of these is going to be working in the wrong direction. But we'll figure that out pretty quickly. And in this case, we're going to say if torque dot z is not 0, we actually need to apply our torque. However, we need to go and change the way that is. So in this case, torque is going to become b global basis dot inverse. No, the torque is in global space. So we're just going to do, I always forget which way around that is. Global basis. Or is it global basis times torque? Might be the other way around. We will find out soon enough. And then we can say b dot apply. Well, that actually should always be rigid bodies. We can only do this logic on rigid bodies. So if that fails, we don't have a B. We know that that's not going to be good. So now we need to always now we need to check, is it applied torque or torque impulse? Every physics, so it's applied torque. Cool. Torque. All right. Let's see if we now have a spring-loaded door. That'd be cool. All right. Oh, it's already open. All right, so we know that that is the wrong way for closed, but doing pretty much what I wanted to do. And the nice thing is that in the open bit, just here in between those 2 degrees, it's going to go right. But in the open bit, that's exactly what I wanted, is, yeah, when I go over that point, it wants to always stay open. Okay, that is cool. All right. So I can probably do that like this. Boink, boink. So we now know that our lower is the one that needs to be negative. Right. File, save. Ah, no, that's the wrong one. That's right, because our lower was the one that, that's funny. Okay, now the other thing which is really important is what we're doing right now is only going to be happy if we're paired to a static body. Okay. Oh, you guys didn't see that. The door was swinging open and closed. So now once it goes to the last bit, then boom, it goes closed. And if I go there, then it stays open. Ow. I just hit something. What am I hitting? Oh, I am facing the wrong way. That's pretty cool. Now I could put it on 45 degrees. At the moment that we're on the halfway point, it closes, and the moment that we're past the halfway point, it opens. But so that obviously that's because we're colliding with the hand as the hand moves away. But yeah, that now stays open. So that's definitely, and you know, the fact that it's so low makes it hard. But yeah, that's pretty cool. All right. Now, if my table or my cabinet wasn't a static body but was a rigid body, then we would have the same problem that we had with our slide. There we go. Okay. Hey, Maddie, how you going? That obviously the torque that we're doing on the door would also work on the other side of the hinge joint. So I might put a remark here to do if A isn't a static body. We may need to apply a counter torque. And that would then also need to be a torque that we might apply on the correct spot. So in this case, and that's the other thing that I may or may not have done right here, although that might not matter for torque. It might be more important for an impulse that the location is correct. So I think with the torque, in this case, will always work on whatever the joint location is. So that should be all right. All right, so we now have a spring hinge joint implemented in a way that we can fine tune it, which is cool. I'm gonna make this a bit bigger. This one too. There we go. I'm gonna make this a bit stronger so that it closes right. And again, I don't think Newton is the correct notation here, but it needs to have a notation of something. So if someone has a suggestion what the correct unit type for torque is, let me know. Might actually be Newton meters or something like that. Okay. Cool. Now we need to do something similar for our drawer. Again, I want to create the same logic that if it's almost open, we apply a force that it stays open. If it's almost closed, we apply a force that will force it closed. All right. And then obviously keeping in mind that our distances are going to be interesting there as well. Okay. It's such a shame that that's actually not in the standard logic here, but whatever. Okay, so boom. Physics helpers, and this is going to be called springed slider joint. All right, let's give it a class name. Bring slider. Oops. Slider joint 3D. Okay. And let's rename you. And it's going to be relatively similar to what we're doing here. Actually, I want to give this a proper name now that we so let's call that rigid body B. Okay. And then that's no, we can't name that because it's already a thing that is named body rotation. Just to give it a little bit more of a name that we can actually relate to. Cool. All right. Excuse me. So, now one thing that's interesting is I'm not taking the original rotation of the object into account. Because we need to, because if our door was already rotated, then it would take that rotation. So we actually need to take out the starting rotation of this. This is where I really don't like the way that there's like hidden logic behind this, where when these things instantiate, it is going to do some calculations. And yeah. Well, that's not too hard to add in. So in this case, we just need to have also a, actually we can do that as an onReady. No, I need to do that as a ready function. Func. Okay. That means we're actually going to make that a normal variable, which we are going to name a private variable, which we are going to go and get over here in our ready function. That means we don't have to grab it again. We just check if we have it. And here we're going to actually say if we don't have that, then we return. Boom. And then there we go. Cool. And that. Cool. And then also we need to have a start basis. Start rotation. Basis. We're actually going to take that as the inverse. So here we're going to say rigid body global basis inverse. And I think we need to do that in front, but I'm not 100% sure. No, we need to do that. No, we need to do that. I don't know, actually. Um, let's just see. We're going to do something weird for this. Just test this. We are going to grab our door and we are going to rotate it a bit like that. Okay. And I'm doing that because that is going to help us check whether we're actually doing the right thing. Actually, you know what? No, let's do it like this. And I actually want to go because with this in our hinge joint, let's go and not do that because I first want to show why I'm doing this. So we're now seeing that this is now at a starting angle, but that's going to make it want to go the wrong way, I think. No, actually, we need to go the angle the other way around. Like this. Yeah, let's see what that happens with that. Yeah. Because I think it's not going to work in one direction and it's going to overwork in the other direction. Because we're not going to get the angles that we are expecting. Okay. You can't close it because this is how far it goes, but you can see that the close logic is, no, it's no longer automatically trying to close because it never gets the angle that we want. And that's already going over the too much rotation, and therefore it's going to go over there. All right. So while the degrees, because of the way that the hinge joint works, part of that should be all right. Okay, but now let's see, does it need to be before or after? I always forget my matrix calculations for that. Okay. All right, so now it's going to try and, too far away. It's going to try and close again up to the 25 degrees. Oh, this is so hard when I need to bend over. I need to add a strength to this. Okay, that's weird. Hmm. Hmm. Okay, that I think is proof that I've got my rotation in the wrong place, in the wrong order. So let's see if I do that the other way around, whether that's going to make more sense. So now we should get the delta rotation, how much more it's rotated. No, that doesn't do what it's supposed to do either. Okay. Why is it doing that? What am I doing wrong? Oh, because I'm so stupid. Okay. Let's get the rotation of the correct entity. Yeah. Okay. Okay. Well, it's opened up again, so We could still be doing it the wrong way around. Oh, come on. Oh, why do I do this with a door that's freaking on the button? Okay, so that is an indication that we are still doing it the wrong way around, which I am actually expecting. Although it doesn't make a whole lot of sense. Because we're only rotating in one axis. So, no, it's still doing the wrong thing. Okay, what am I doing wrong here? What am I doing wrong? All right. Bring another angle again so that we can see what we're doing. And obviously, right to dig. And let's just return early here so that we can just see what it's doing. That's the bases. Lower bases inverse. No. It's a normal basis inverse. That's my problem. Okay, let's test this hypothesis. I think that my problem is I should not be correcting in global. I need to correct in local. All right. The door is on its closed position. Because again, for the hinge joint, this is 0 degrees, even though our door is slightly more. So that wants to keep going closed. Okay. All right. Now I need to somehow try and get this, yeah, past the 25 degrees. I'll be glad when we're done with this door because I hate bending over like this. All right, I think that was the mistake that I was after. Cool. That looks good. Yeah, now the only thing that I might need to figure out is, no, I think that is correct in that way, because we're going to go for local. You should probably raise the door off the ground. Yeah, probably. That's probably a good idea. So I'm done with testing that one. And for the drawer, I don't have to actually bend over, so that's kind of cool. Let's go and make sure that our door no longer has its dumb, oh, that one, no longer has its dumb beginning rotation. There we go. And let's work on our drawer. Now with our drawer, we have the same issue. And here's actually a bigger issue because we can see that our drawer is slightly there. Now, why is our select? Oh, that's probably because of the graph points and stuff. Okay. So our point is here. So what we want to do is we want to know how much it's moved from a starting point to where it is now, but then in the local space of this guy. And because we're just working with positions, we can make our life somewhat easier, I think. Let me think. Yeah, because we're just looking for hmm. I think in this case, I think that matter. Yeah, because we're all working in here. So yeah. So I think in this case, we take our global position, take off our local position here. Why is this one so much more tricky? Because we're not going to be it wouldn't be tricky if we would be using full matrices or the full transforms. But because I'm just going to work with locations, it may be more challenging. No, we can make that work. We just need to be a bit more smarter about it. Because again, we could do the whole transforms, and then we could do exactly the same thing as we did with the rotations. We could start with an inverse of the local transform. And even that is kind of actually wrong, that what we're doing. I should have actually done that slightly differently, but again, with rotations, I'm not too worried about it. It would have gone wrong maybe if this one was rotated and that one too, because we actually need to have the combination of that. Yeah, I'm not too worried about that, to be honest. Misty, come on. Stop playing with my green screen. Cats. Oh, you found that thing. That's what you're playing. You found your toy. You're not supposed to play with that like that. That's supposed to be on a thing. You want to play, huh? You want to play, pussycats? She dropped this little toy thing on the floor. No, we're not going to play with that right now. It's too late for that. Ah, crazy cat. Okay. Yeah, so normally if we do that, then we would get that just fine. But we just need the amount of movement. Okay, we're gonna do it like that. Okay. So I think even with our hinge joint, I think that, you know, if we have compound rotations, we might get into trouble. But we'll do it more properly with this one. It's actually easier. And hey, definitely do not do that, cats. That is not a scratching poll. You are being very naughty tonight. That is not a scratching poll. That's a green screen. Yeah, you want to play, but it's too late for that. Then again, that's the problem with cats, of course. For them, right now, it is the optimum time to play. Okay. So we are going to go a little bit more of that. And we're going to say start pos vector 3. And in this case, our start position is actually going to become our rigid body dot global position. So our current global position. In the local space of our joint. And in this case, what we're going to do in our process function, in our physics process function, is we're going to do the exact same thing. We're going to call that now new position, because now we're having a new position, get that into the local space. And I do like to type that, even though that's a little bit superfluous. Okay, so now our movement vector is our new position minus our start pos. New pos, not pos. Okay. And let's go and print that out and see what we get. Because we now, in theory, should be getting a value between 0 and 0.75 on one of the axes. And we'll figure out which axis that is. Alrighty. Hey, Push, what are you doing? You were active all of a sudden. You were sleeping a minute ago. All right, let's try this again. All right, so now we're dealing with the drawer, which is in a much nicer position. Let's see what the starting position is. So it's all pretty much zeros. That's fine. That's a rounding error. Come on, stay open. And that's going on the X to minus 75, exactly what we're expecting. So we did that a lot better. Cool. All right. And that actually gave me an idea on how to improve our hinge joint and make that more reliable as well. But we'll come back to that after we make this work. So here we're again going to create an upper and lower limit. What the heck are you doing, cat? Range. No, actually we don't want that range. We just want that normal value. Lower distance. No, actually, we're just going to do that 0 as a default. Var lower force. That shouldn't be that. That needs to be a float. So those are floats, and that means that we're going to go make that a range. But this actually does need to be a bit higher. There we go. What are you complaining about? And then here, upper distance and upper force. Okay. Okay, so we're going to do exactly the same thing that we did in the other one. We're going to say if movement smaller than our lower distance and lower force bigger than 0, then we're going to apply the force in one direction. And if it's bigger than the higher distance, higher force, then we're obviously going to do that. So obviously now we need to have a variable for force, which again is going to be a vector 3, which we're going to make 0. And in this case, our force is going to be on the x scale. And that's just going to be lower force. Now, if we're going to go smaller, 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 we're going to have a positive force to push back. And this is then going to be in the opposite direction. There we go. And now we can say if force.x is bigger than, no, not equal to 0. So if we have a force to exert, oh yeah, move input dot x. Oops. We're doing everything in the x direction. Okay. So in this case, we're going to go and apply a force, and we're just going to apply a force on the center. So on our rigid body, apply, and again, is it apply impulse or is it apply force? Impulse is actually not apply force, position, time dependent, and meant to be. Okay, so it is our apply force. Why is it? Oh, it's because upper distance. Upper. No worries, Ad. I'm glad you enjoy the stuff that we do. All right. Apply force, thank you. Force. Now, obviously, that's the other thing. With forces are applied in global space. So we need to go and take our force, and we need to go, actually, I think we did that with the other one as well. We're going to do our global transform. Is that, do we need to offset that? No, we should not offset that. We need to do just, we just need to rotate that in the, it's a directional vector that we need to rotate into the correct space and then apply it. That should do it, I think. Let's go and see if that indeed does it. All right, so. All right. Be a miracle if we got this right the first time, but you never know. Okay. All right, my hand of force was stuck against that. And that doesn't seem to be doing what I'm hoping it to do. It stopped. Why does it stick to it? That's weird. Okay, doesn't seem to be applying the force that, oh, because I haven't set it up. Might be handy if I actually set it up. So our lower distance, we're going to minus 75, minus 0.75, I think it was. Yep. So let's go and say that that needs to be minus 0, excuse me, 60. So that's 15. And then let's just give it a small force and see if that's good enough. And then this should be minus 15. That's the upper version. And again, we're just going to keep it to 10 newtons. That might be way too much, or it might be way too little. Meow, meow, meow. Okay. Meow. Okay. Okay, so we are doing the force in the wrong direction. But other than that, it is doing what we want it to do. Okay, we can do the same thing as before. Come on. Sorry, guys. It's not bringing up my start bar. There we go. Okay. How are we printing that nicely? And boom. We're going to remove that. And add that in. And then we're going to go and save that. And then obviously I need to make sure that you guys can see what we're doing. There we go. Alrighty. So now, that's a pretty decent force. And then the last bit, it closes. All right. So still not happy about the fact that when we let go of the handle, our hands are colliding. Now I could possibly do more with maybe push the grab points a little bit more forward. But that bit works. Okay, one thing that I can probably do, I've got two hands. Okay, so now it's going open. Okay, so yeah, we're now in that part where we're not open and not closing. And then when it's nearly there, then boom, it goes there. I think maybe the 10 newtons are too strong. Yeah, let's just close you. Let's change it here. What is it, cats? All right, let's also get rid of that because that's just printing overload. Still printing even though we stopped playing. Let's just do 1 newton and see if that's... No, not 0, 1. Why doesn't it like 1? Oh, because I'm not allowing it to do it in increments of 1. Which I think is kind of... Well, seeing 10 was pretty strong, I'm actually gonna make this much more adjustable. Maybe just do it a little bit more than that. Let's see what just 1 newton does. Okay. Okay. Okay, so that's the point where it's no longer having any force. And then it blows. That's actually a really nice amount. So I'm just going to adjust the grab point a little bit so that it hopefully doesn't collide when I let go. Again, that's one of those things that will eventually solve when we do either automatic posing or something like that. Yeah, let's just move that. Oh. What? And again, I know it's not touching, but oh, why is that the wrong way? Oh, because that's left hand. That should be right hand. There we go. So yeah, I was afraid of that. It was definitely moving it wrong. Okay. Let's go to the other grab points. Same deal. I don't want it that close. This is left hand, right is off. Very good. And we'll all make this work a lot better when we get posing all to work. All right, let's see if that makes more sense. Okay. Oh, that might be because no, still every time that we let go, the moment that that'll let go, it oh, I can see it is very close, and it immediately rotates and gets in there, and that's the problem why it gets stuck. So yeah, that's something that I need to figure out and see how we can make sure that when we undo our joints. Oh, that suddenly went okay. That we don't. Oh, that's because I just knocked it in. Yeah, it is what it is. All right, let's go fix up the rotation, and then I want to do a door, and then I'm gonna call it a night. So let's go change this so that it actually works the same way as the other one. And the thing that I actually want to change is this rest vector, because what we are interested in is the angle between our start and where we currently are. So instead of doing this, we can just get our starting vector. All right. So what we're going to do is we're going to take this guy out of here, and instead I'm going to do this calculation here. I'm going to call that start body rotation. No, I'm going to call that, I'm going to keep that body rotation. Because we want our rest vector to be replaced by our starting vector. Now, the only thing is, no, I think that's going to be fine. So, we're actually going to call that start vector, vector 3. And we're going to go and say this, we just get our x. So, all bases inverse. We get our starting rotation in the local space of our hinge joint, and we save that. And that means that we can now do these two, compare it with our start vector. That should always work. So let's see if that indeed does. Now, and that also means that this time I am going to go and move this up a bit so that it becomes easier. And we'll move it back to the ground in a bit. But it also means that we're going to go and take our door, and we're again going to give it a start rotation. Let's make it start rotation outward so that it becomes easier to test. And let's see if it still works the way that we expect it to work. All right, this guy's nice. Where was actually my camera? Why can't I see my camera anymore? Oh, there you are. Okay. Okay. Oh, don't do that. There we go. So that last bit goes open. and I just threw it closed. Okay, let's stand in a bit of a better position. So that is still in our minimum. Still. How did that hand suddenly get there? Oh, that's there. I still don't get why our door is like that, because we do have a backplate. I might turn two-sided on this material. I think it's just that the um, that face is the wrong way around. Anyway, that's working. So I'm happy with that change. That makes that a lot more reliable. Yeah. So is that then indeed, if I just go to the door here and I go to, that's not the one I want. On this one, the wood one. Now I say copy. And I'm going to go over here to service override, and I'm going to go say paste, and then make unique. Disabled. No, we definitely do not have internal. That's sad. Huh. Well, that still gives a good reason to make that double-sided. So I'm gonna, actually one thing that I'm gonna do now, I'm actually gonna clear this out. Clear, yeah. I'm gonna go back to our file system. We still got our cabinet selected. I'm gonna go to our import tab. Oh, I need to reselect that. Here we go. I'm gonna go to advanced. And then in actions, I'm gonna say extract materials. And we're going to make a folder here called materials. There we go. Select current folder. All right, so that's going to create a wood, metal, and default material. So those are the materials that we're going to extract. Now, the nice thing about this is that all these assets from Kenny are all using the same names for these materials. So if I do the same thing on some of the other ones, still weird that this is not lining up, but anyway. Even though we know that it's lining up here. So now we know that that this is using a material that's actually saved on disk. Where are you? This jumps around so weird. So that's not saved on disk. And any of the other ones that we export, and we'll try that out with the door in a minute, will then use those same materials. Now, the next thing that's really cool with that is, let's go to that material folder, and let's start with our metal material. So the first thing that I want to do, even though it is a little bit more, it costs more performance, is I do want to make that double-sided, so that at least we don't look through a non-door, even though I really wish that that door had a backplate. So, Mr. Kenny, if you're listening, make sure your objects are solid instead of that. But the other thing that I want to do, because this never comes across in the conversion, is that I actually want to drop our roughness a bit. And I want to actually up our metallic a bit. Maybe a little bit less than that. Now, here we don't really see very good what that does, but in our main stage, let's actually, first of all, move our drawer back to the ground. I don't think I've made it metallic enough for it to really matter. Let's therefore go and up the metallic even more. Let's go to that 0.8 after all. We can see that that starts to shine. Because here we got a nice HDR for it to reflect. Let's bring the roughness down even more. And we start seeing stuff being reflected. Now we got lucky that it does look like it's reflecting this floor. It's not. It is actually reflecting that. But we could, of course, put a what you call it, a reflection point in there if you really want to. Could you just duplicate and flip the door in the meantime? Probably, but you know, doing this is kind of okay as well. Now the other thing that I want to do, and for that I'm going to go over here. 1 second. Let's go and look at some of my older stuff. Okay. This was an older test that I had. And these had some nice wood textures. So can I preview that? So that's a really dark wood. Is this a light wood? That was a light wood. That might be nice to use. Let's go and grab that. So that's from CC0 Textures. So let's go in here. New folder, CC0 Textures. I don't know if there's actually UVs that we can use. So this might be a dumb idea, but actually, let's go get rid of these because they're all Godot 3 import files. They're not going to do much good. I also don't want this stress file here. That's just dumb. Okay, so when I come back here, it should import those new textures. And now we're going to go to the wood texture here. And let's go and load in our wood texture. Okay, there we go with that. Damn, it always screws that up, doesn't it? Let's go and turn you back to white, or else it doesn't apply it properly. There we go. Okay, I might need to do the UV a little bit better. I don't think the UV is set up that good. This is probably a too dark wood still, but just for the idea that, you know, this is one of the things that I do really like about Kenny's things. Is generally speaking, you can really dress them up really quickly with a couple of textures. Oh, that's not linked. Okay, that's fine. Yeah, that's much better. That looks nice. Okay. Do we want to go a little bit crazy and also add the normal map on there? Why is there an emission here? It shouldn't glow. Wood doesn't glow. That is no, don't do that. Let's see, normal map. There we go. See if that makes it look nice. It doesn't make much of a difference. A little bit, maybe. Okay. The other thing, of course, is the wood needs. It keeps deselecting that. That's the other thing that's annoying. So we're gonna turn off our back face coming. So now at least we do have an inside of that door. It's not pretty, but it is what it is. Now the collision shape of that thing is crap as well, which might be why our hand keeps getting stuck on it. But yeah, the other thing that we could do is, you know, we could put a manual collision shape on that. Maybe that's something that I should do. Oh, look at that. It's kind of cool. I think we might actually do that. So instead of this concave, we're just going to do a box shape. Yeah. That's at least our collision shape makes sense. And it also means there's no collision on our little door lid thingy here. Oops. So that might also mean that we get less problems with that. Now, I could probably do more with collisions on that guy, but that's all right. This is something that I really like, is even though we're importing GLTF with all the settings, we can overrule stuff. And it will just take that. Now, the only problem that I have... Yeah, I think it would. Let's go and reload that, just in case that it's going to throw it away. Okay. Collision shape is still a box shape. Okay, so it does remember that. Yeah, no, I think those sort of overrules. You can't change the properties of something that's imported. Those are undone. But I think if you create a whole new one, it does have an override for that, which is kind of cool. Let's also go and put our door back to the normal angle. There we go. So with that, we have our door properly working and our drawer properly working. And we have a much nicer looking thingy. Cool. Pretty happy with that. It's already midnight. Let's do a door. Just for fun. Because a lot of what we just created we can reuse for the door. But something that I want to do with the door is I want to see if we can make the door only open if you actually press down on a door handle. That would be really cool. And we'll have to see how that exactly works. How we can make that work. Especially how we can make the door lock again. Okay. I think I have a nice idea how to use our spring hinge joint for that logic. Because what we're going to do... Oh, I'm out of water. No, we'll see. Because we might just need to turn... Oh yeah, we can change the door to... we can change that to be frozen. That's a way to... Anyway, let's start with finding a door to play around with. So we are going to go back into our main stage. Actually, let's go and close some of these other things. It's getting a little bit full. I want to keep that way. All right. So here's our cabinet. Very cool. Let's go again. We just create a node 3D just as a helper node. We're going to call that door. And let's start with just putting in a door from here. And then we're going to start setting it up again. So where do we have a nice looking door? And now I'm hoping that we have the door with... Okay, let's do this one. Obviously, we need to go and actually, we're gonna go to the... Oh, I am an idiot. I need to position it by moving our root node. And let's go and do 90-degree turn down. Let's go and save branch as seen. Go on door. Not. Cool. Okay. Add little children. Oh, that's the doorway, and that's the door. Okay, that's cool, because we need those like that. All right, let's start configuring this guy. So let's go back to import. And we're going to go to advanced. Now let's keep our scale the same. So I think we had our scale on 5. Now let's go and make our doorway a static body. Very good. So decompose. Okay, we can't really see what it turned that into. No idea if that's any good. This guy's also physics, but this one is going to be dynamic. And in this case, because it's basically a square, and unfortunately we do have a handle on this. That sucks. Just simple convex. That's still trying to. Oh, it's doing it back down. Yeah, we might change that to our own. But I don't like that we have that. So let's go and have a look at the other one. Also has a thing. Hey. Why does a door have a door handle that is not a separate object? That shook. Oh. I did not press re-import. That was not smart. So we lost our changes. Compose. Door. Dynamic. Actually, just do box. Which is not defined. But that's okay, because we're going to make our own. Okay, so. All right, that's just hilarious. So obviously our collision shape for a doorway doesn't work properly. Let's just make that a tri-mesh. And of course, it's, whenever it's scaled, it's not positioned right. That's funny as. And our door, can't see our door, but that's okay. The other thing that I want to do is extract materials. I'm going to go into the material folder and we're going to extract there. And you can see that we're actually going to be reusing our wood, but we're going to get a new metal type. Not sure why we can't use our steel, but we can see that our wood texture is immediately, actually, was that already steel? Oh, it wasn't all metal. Okay, so it's actually applied the exact same materials there. And that is one of the things that I find so cool of Kenny's assets. But yeah, unfortunately, that's a solid mesh, and we're just going to pretend that it's not, but it is. And that's a shame, because I really wanted that to be something that we could animate. We're going to just pretend that it's animating for the purposes of what we're doing right now. Now, the other thing that I like is that our origin point is actually there. I do, however, want to go and move this in the middle. Okay, that's interesting. Okay, this one is actually in the right spot. Okay. Nicely in the middle. Yep. So I'm gonna do something weird. I'm gonna do our spring hinge joint over there, and then I'm going to move it over there. And that's just so that it's in the right spot. Cool. And now we're gonna go assign that to our door. Sorry, to our static body. And then assign that to our door. And of course, we are having the same issue that this thing is not rotated correctly. And now, as far as our parameters are concerned, our limits, we turn on our limits. So we have this slice. And in this case, we actually need that to be the other way around. So we're going to do that as -90. Or is it that slice? I'm not sure. -180. Zero. So I'm guessing that that's going to be our arch. Cool. Actually, not cool. I want it to only be opening it up in one direction. So open that way, close that way. So with -90, so this is actually 0. -90 is closed. Okay. And now we need to do this. So let's make that -10. And that is -80. Okay. So at the moment, our door should just work normally. However, our collision shape on our door is a box shape that is not right. So we're actually going to create a new box shape here. And now we're going to go to our left view so that we can nicely see what we're doing. Gonna move you up, move you back, move you back, move you up. Good enough. And then let's say front view, back. This is where it's so annoying that we can't actually see. And so this one, yeah. About there. So again, only the door is doing that. So now we should have a hinge joint that when our door is almost closed, it should close the final bit. And when it's almost completely open, it should stuck open, but it should move fine in between. All right. Hey, Eriko, how are you going? Well, I am almost rounding it off. I don't think I have a lot more in me. But yeah. That looks really small. Did we actually size it? All right. Did we do something dumb with the cabinet drawer? That's good. That's good. Okay, cabinet. Now let's go. Where's the door? Okay, it didn't scale up to 5. And now we have the same problem that everything is positioned wrong. Okay. Well, obviously now we need to resize everything again because it's all wrong. But that's okay. Let's go and put that over there. No, we don't want to do that. That's actually still relatively in the right spot. So it just needs to go a little bit like this. And actually, I want you to be nicely on the line. That means that our doorway and our... Oh, that's going to move with it. I'm going to move that somewhat more like this. And now I want that to be somewhat in the center as well. Okay. Okay. Cool. And now our door needs to go nicely back in place. There we go. Okay. Why does our hinge joint change so strangely when I move it like that? That makes no sense to me. Those arcs make no sense. I don't know. We'll see what it does. Let's hope it's just the gizmo drawing that is screwing up. Anyway, there we go. Cool. All right, so now obviously our collision shape is going to be all wrong. Okay. That's okay enough. That's okay enough. It's okay. That's good enough, I think. Let's see. That way. Let's go like that. Okay, that's good enough, I think. All right. Hopefully, this way, we have corrected it. Now, that's a really, really big door. So I think with scaling everything up by 5, yeah, that's way too big. Which sucks that I did not realize that sooner. So yeah, we upscaled the cabinet way too much. That's really what it boils down to. So let's redo this again. All right. So now that is, I don't know why he suddenly changed, but now that is somewhat more the size of what it should be. Okay. Does mean that right now we need to go and move this nicely in the middle again. And this guy needs to move some more that way. This guy needs to move that way. I actually want you also to be more in the middle. The doorway itself should be more in the middle, which means that the door moved again. Middle, that's good. So that's nicely in there. Okay. The hinge joint seems to be pretty much in the right space still. Left view, collision shape. Okay, so this needs to be a bit more that way. This needs to be a bit more this way. That one's good, but it's too high now. Like this, okay. And then you get in a little bit. Perfect. That's good enough. Cool. We have a door. The door nicely next to the cabinets. So yeah, the cabinet is oversized, but I kind of like that. But the door is now a normal size. Hopefully we can move through the door. So let's go and see if we can actually open the door and move through it. Now, I don't know if we need to push the door open or if we need to pull the door to ourselves, but we will figure that out soon enough. Oh yeah, that's gonna not work because Steam Link is not up and running. Key. Yeah, I know. They're not gonna work. I need to close you again. Connect. And of course, it's going to error out because it says like, hey, your current Steam session is not the Steam session that I'm expecting. Well, why don't you just start a new session then? Okay, here we go. Okay. We have, hey, my textures aren't loading. That's interesting. I wonder why. Okay, that is opening and it nicely closes, so our hinge is still working. And now it opens. Yay! I don't know why my textures are not working. Dang it. I'm hitting something again. Oh, sorry, Chris. There we go. And then it closes. Okay. All right. So now something that we want to do is we want to make sure that the door can only open if we grab... Whoa, what the hell is that? Okay, that's a bug. Why would it do that? So it's trying to move the door in a way. So we're actually overpowering the door there. That's kind of cool. You know, that's another thing to solve at some point. Anyway, the problem is that we can't actually grab this handle. And we want to have a separate little object that we can grab there. That we can pretend is the handle. Okay. I should not be able to push it more that way. Obviously, I can't exert too much force on the door. It's really interesting. So the hinge... I wonder why. Anyway, I also wonder why my my textures have suddenly gone. Okay. Because I've got my textures here. And when I load, my textures are gone. That is weird. Okay, let's do this. Yes, Lucky, I'm using Jolt. This is Godot 4.4 with a built-in Jolt integration. All right, all my textures are gone. Huh. Let's go have a look at that first, because that means it's overwritten my materials on re-import. It's not supposed to do that. Oh, I hope someone didn't suddenly decide that that was actually a bug and that shouldn't work that way, because then I'm going to be upset, because that's the whole thing about being able to tweak these. So let's hope that there is a tick box that says, do not overwrite existing materials. Okay, create shade, Let's see, is it on this? So enabled is being saved, is being saved. Is there an option that says, do not overwrite the materials when they already exist? Because if that's changed, then I'm going to be really pissed off. Okay, that's gonna have to be a question to ask the rest. All right. How do I solve that? Or is there something maybe in here that is not in the other one? Apply root scale, input skeleton, tangents, create shadow, imports. Okay, let me just ask that on this. Where would that be a good asset pipeline? I'm wondering if this is a setting I'm missing, or if I'm doing something wrong. Right, what is a workflow that I configure save materials separate payload so I can tweak materials further. I just noticed that materials can't over clicking on a re-input. All right, let's see if we get some feedback on that. I'm not going to waste time on that right now. Well, let's actually, for fun, just change this one more time. Go. Make that back to white. There we go. Does that also mean that my shading? Yeah, that'll suddenly turn off again. All right, save. All right, now let's go back in here. Let's actually go and close this and close this and close this. And now I'm going to go to my door and I'm going to say re-import. Now I'm going to take over to materials. This time it's worked properly. Okay, let's go to my desky thing. Where's my desky thing? Which was the cabinet that we were using? This one. Let's go re-import. Okay, so far so good. Current project. Let's just see if it stays. Come on, load up. Okay, so far so good. So maybe it's a fluke. Maybe I drew conclusions too quickly. Let's see if it actually keeps the color. Yeah, this time it stays. Okay, that's weird. Oh, I think, okay, let's put this to the test. I'm gonna go and do this. File system. Objects, materials, no. Let's just do this cabinet bed drawer. And we're gonna go to advanced. I'm gonna make that 3. I'm gonna say extract materials. And I bet you that this is it, because I'm now telling this one to extract materials. It is going to overwrite it. Cancel. Okay. Okay, let me just put that on there. Oops. Objects. Do we have a option to skip that? No, we don't. Now, I do think that what I can do is I can go to, hold on, let me resize this. So if I do save the file, no, that's not for that one. I want to do that on the materials. So wood, and the external, and now I can go and, what's that? So that's wood. That's metal. And that's default. Re-import. Okay, has it now overwritten them? Now it leaves them alone. I don't know, what is that called? Okay, so at least I know why it went wrong. And what I need to do to prevent it, I guess. So I've got that double-sided again. I've got that. Roughness can stay. Metallic can stay. It should not be an emissive material. I have no idea why wood would be emissive. And obviously we want that. Okay, and then this guy, similar changes. We need to do that disabled because of the bug and Kenny thingy. We can keep that. That also shouldn't be emissive. That should be fairly metallic. That shouldn't be very rough. And the rest can stay the way that it is. And now we can load our main stage and we should see nicely. Yay, that's all good again. All right. I'm actually going to leave it there, guys. I think we have a working door that we can push open. There's still some little things to fix, but that is something to do in due time. We have a working drawer. We have a working little door on our cabinet. So I think that is pretty cool, and that just gives us a bunch of testing elements. I'm going to move these a bit to the left. They're too close to the thing. Yeah, that gives us plenty of things to test around with and improve the physics logic around this. And yeah, make sure that things work better. Now, of course, one of the things that I can also do is make sure that the door is heavier. That would also help a lot with, so that's probably a good idea to do anyway. So if you look at a door, let's make that 5 kilos. I don't know if that's good or not. Let's actually see. Maybe we can't even open the door anymore now. But that's a good thing to just try. Oh yeah, and see if our materials stick around. Oh yeah, I still need to adjust the UV. So yeah, I can open that. Oh, look at that. And that falls open. So yeah, now it has a bit of momentum too. There we go. I can close the door. Now, it still has a bit of bounce, but again, if yeah, that's still not working correctly. So it really doesn't like the fact that it's okay. So that's definitely something that I need to figure out why it's doing that. I think it is because we've got force proportional to distance, and we're probably just overpowering it. So yeah, that is a thing to still fix. And then I need to see if I can actually get something with because the idea that I've had. Actually, that's one thing that I also want to try. Let's freeze it. I just want to see if I freeze it, if I can no longer do crazy things with it. Because the idea is that we keep the door frozen when it's closed and the handle isn't being pressed down. And then, so yeah, we can't do anything with it. I can't grab it, can't push it open. No, perfect. So that's the way to then trigger that. So obviously what I want to do is when the door falls closed and the handle isn't being pressed down, that means that it immediately freezes and locks the door in place. And when you try and open it, you have to use the handle to open it and push the door open. But it is almost 1 a.m. I am getting tired. So that is not something that I really still want to do tonight. So let's do one more thing that I do need to do because I just noticed that oops, that's a different thing. Oh, Misty is, my cat is playing with the Godot plush. I hope my Godot plush is not gonna break. There we go. Maybe even a little bit more. There we go. That makes that look much nicer. Let's see how that looks in here. Does the yeah, that looks all right. That looks all right. Okay, let's see what that looks like in the headset. That's the real test. Now you guys won't see that too properly because I'm not moving the camera yet. Well, that was the other thing that I wanted to start spending time on is the camera movement. Yeah, that looks like a much better door. Cool. Sweet. I am happy. I'm going to leave it there, guys. I think that is more than enough to play around with and to see. You know, we've got a whole bunch of things working. We've got drawers working. We've got a door working. We have a whole bunch of things to fix, but that's what we get with brand new logic. And we'll just see where that goes. So, yeah, that is where I will leave it tonight. So, thank you all for joining. I hope it was interesting. Yeah. I will see you guys on the next stream. Only my cat will be nice.